From the College of Business and Economics at Boise State University, I'm Regis Turpin, and the topic of this video is product development, tools, and techniques.
Before I talk about the tools and techniques used by manufacturers, I'd like to point out the fact that over the last 20 years or 30 years, there's been tremendous improvement in the area of product development. This is something that I'm trying to illustrate with this slide here. So you could see that in the area of the car industry, for instance, the product development time went from 60 months, that's 5 years in 1980s, and it went down to as low as 12 months nowadays. So that's a significant drop, as you can imagine. And some of that has been prompted, if you like, by the team approach that was mentioned by Pat Shannon in the other video. But a lot of that was also generated as a result of some of the tools that are in the other slides. So the first technique that is used in product development is called reverse engineering. And reverse engineering is simply the fact that a company is going to buy a component and is going to open and disassemble it and look at the feature, the way it was assembled, and trying to learn from it. There are some potential legal issues, so although there is nothing wrong about buying a product and opening it and try to learn from it, it's what you're going to do with what you learn that could be problematic. Are you going to violate some patent, for instance? That could be a problem. For the company that is victim of that, of course, it is tricky in a sense that it's not always easy to prove in a court of law that someone did indeed copy the design of one of your products. And since the burden of proof is on the company that owns the patent, that can be tricky. But so that's one of the technique. Another technique is called design for manufacturability, and some textbook will call it design for manufacture, more simply. It's one thing to come up with one prototype that is working and functioning well. It's another to come up with a design for a product that is going to be easy to reproduce and to be used for mass production. So the idea of design for manufacture is that companies are going to have from the beginning to try to design a product that is going to be easy to assemble. And typically this means using a minimum number of parts. Having too many parts makes it more difficult and more likely to have mistakes, defects. Using a modular design is another way of doing it to make it easier to assemble. Simplifying the processes and operations to make it easy to do the assembly perhaps without tools, etc., etc. Here's an example of design for manufacture. This is an example from the 1990s. There's a company, NCR, that was making a cash register. It's like a point of sale terminal, if you like. And they did a tremendous reduction in labor time as a result of their effort in design for manufacture. They used 85% fewer parts, 65% fewer suppliers, and design it in such a way that there was no tool needed for assembly, no fastener. All that resulted in tremendous saving for the company in the millions of dollars. So that's one example of how it can be used in practice. Another example of technique is called a robust design. So robust design is about making the process insensitive to variation, and more specifically designing the product in such a way that depending on where it's made, by whom it's not going to be too much affected by those variations. So that's what is illustrated in this diagram here. You see that in a robust design, a large amount of variation in the input is going to result in a smaller amount of variation in the output. And ideally, I would say that this variation should be almost zero in the output. A good example of that is something that was illustrated in the McDonald's video.
We can come up with those great ideas very quickly in this kitchen because we're trained culinarians, but how do we take that product and transition it into our restaurant so that an 18-year-old, a 20-year-old can do it that is working in our restaurants?
Design for maintainability is another technique which states that a product should be designed in a way that makes it easy for the consumer to maintain. It's also called design for serviceability depending on where you read about it. So a good example of that is something that you may have experienced with your own car, and I'm going to share my personal experience here. When I was in Phoenix studying for my doctoral degree, I had a Taurus, a Ford Taurus, and one day there was a problem with the air conditioning, and as you know, not having an air conditioning in Phoenix is not an option. So first thing I did was to take it to the garage. The mechanic told me the part, which is the evaporator that you see at the bottom here, costs only about $150, but labor is going to be the bulk of the cost. And that's because in order to install that part, you need to remove the entire front panel of the car. And I found a picture actually illustrating that online. So that was about 6 hours of labor to remove and to put back. So the total was over $1,000 of work, but only $150 was for the part. So that's a good illustration of poor design for maintainability or serviceability. In this case, it is too difficult to access the part that needs to be serviced. Another example of that is in the area of computers. If you look at the computers of the 1980s or 1990s, it was kind of this scary black box that nobody wanted to open. But if you look at the more recent version of PCs, and I know most people don't use PCs anymore, but um, this is the kind of things you would get. So a box that is easy to open. You don't even need a tool, and there's a window, in fact, to look inside and perhaps detect problems um, without even opening the box. So that's another example of design for maintainability. Another example of technique is called design for sustainability. It's a more recent technique. Um, Basically, the idea is that you're going to design a product or service in a way that you're going to try to minimize its impact on the environment. And there are several ways this can be done. The first way is by the use of some material that are easy to recycle. That would be one way. Another way would be to design the product in such a way that you can dismantle it and reuse it in a manufacture of another product. The third way would be to design it in such a way that it would be easy to disassemble. For instance, because there won't be any need for special tool, it could be done by hand and very easily. So those are some of the examples. And I'm going to show you an example that is not a good design for sustainability. So that's the example of a razor, and you see that for a simple product, how many different parts are being used, and the fact that in order to disassemble it, you need some special tools that would take a long time and would be very labor intensive. So that's a good example of something that would be not a good design for sustainability and difficult to disassemble. Prototyping is the last technique I'm going to talk about today. Below, we're listing some of the prototype. Just show you a couple of examples. The first one is done by a company called Audi, which is a German car manufacturer. You probably all know about it. So they use clay prototyping as a way to test the design of their cars. Clay is great because it's very easy to shape the way you want with a minimum amount of work and investment. And once you're done with that, you can paint it and show a copy to a focus group of your best customer or potential customer and see how they react to it. So although it is pretty pricey to do, it's a lot cheaper to do that way than to fail because the product didn't respond to the need of customers. So that's one example. Other type of prototyping. So you see that on the left here, you see an example of a computer design. The nice thing about computer prototyping is that not only you can visualize the product, but in some cases you can even start testing it for aerodynamics, for instance, in the case of an airplane, and do some of the primary testing on the computer before even having any tangible uh, prototype that you test in the real world. On the other hand, on the right, what you see is a real small scale prototype of an airplane that is being tested, in this case for aerodynamics in a tube in this case. So that's another type of prototype.
This concludes our video about new product development tools and techniques.